Okay, this video is going to cover the law of cosines. So we'll talk a little bit about what the law of cosines specifically is, as well as getting into an example of solving for a side and solving for an angle with the law of cosines. So just like the law of sines, the law of cosines is a rule or a formula for solving for non-right triangles. And it uses the exact same conventions, capital angle or capital letters for angles, and then straight across lowercase letters for the opposite sides. So it starts off based on this one. The specific letters we are going to use doesn't really matter. Just remembering a couple of big things once I write down this formula. So our formula goes c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. Now there are really two important things that we have to know here. The first being that these two here, big C angle and little c side, are the only things you can solve for. That might not technically be true, but if you are trying to solve for A or B in this equation, you should probably be using the law of sines. It is going to be much, much, much easier. The other thing to know then is that A and B, where they show up, are just your other two sides. It actually doesn't matter which one is which. It really doesn't even matter that you're consistent. A and B are just your other two sides. You do have to know both of those. Again, just like last time, there's 4 variables, little a, little b, little c, and big C. You have to know 3 of the 4 to solve for the last one. The other thing you might have noticed, and is more just an interesting thing than actually having to do anything with it, you might notice that that's the Pythagorean theorem right there. So this is very much related to the Pythagorean theorem. And it does, in fact, work on right triangles. And if you play around with that, you might be able to find out why when you try it. Okay, let's go ahead and do a couple of these. I'm going to start by solving for a side because this is the easiest way to do it. So I'll draw out a triangle. Not going to be drawn to scale. We're going to say that's 100 degrees, 6, 10, and we're solving for x over here. The first thing that I would like you to notice is that we cannot use the law of sines on this one. We do not know a pair. So I have an angle here, but I don't have the side. I have a side but no angle. I have a side but no angle. Can't use the law of sines. The only time you really want to use the law of cosines is if you can't use the law of sines. So I'm going to start by writing out my formula. C squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. And I'll start plugging these in. Remembering that the only two things I can solve for are either angle C or side C. The side I'm trying to solve for, x, has to be C. So I'll go ahead and put the x there. A and B are my other two sides, so 6 and 10. 6 squared plus 10 squared minus 2. And I'm going to go ahead and put these in parentheses. I could have put them in parentheses over here, but I didn't need to. Over here, it's going to make it much more clear that this is 2 times 6 times 10 instead of 2,610. Times the cosine of my angle, the one that's across from the thing I'm solving for, is 100 degrees. Now, here's the best part about using the law of cosines to solve for an angle. We are 99% of the way to this thing already being solved for x. Right now, it's x squared equals. So the first thing I'm actually going to do, I'm going to grab my calculator right away. I'm just going to type this whole right-hand side of the equation in. It's still going to be x squared equals, but I'm just going to go ahead and figure out what that number is. So I've got Desmos. pull it over here, try not to cover anything up. And we'll just start typing this in. 6 squared plus 10 squared minus 2. I'm going to put parentheses. 6 parentheses 10, close that parenthesis. Cosine of 100 degrees, close my parenthesis. Now it is 156.8. I'm going to go ahead and hit enter. And I'm going to write down x squared equals 156.8. I'm actually going to keep going. I'm going to write like dot, 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 dot. It keeps going. I'm not forgetting about those. We'll talk about how we deal with that in a little bit. So at this point, almost there. We got to remember back to when we talked about solving x squared equations. If I have x squared equals a number, the inverse operation is the square root. So when I square root both sides, the square root of x squared is just x. And this is what I've got to type in my calculator. What I'm not going to do is type in my calculator the square root of 156.8. I don't want to do that. I want the square root of 156.8377813 plus all the numbers that are continuing to go on and I don't see. So the way I do that is using this answer key right here. So I hit the square root and I hit answer. And what that does is it just plugs my previous answer straight into that square root function so that I don't have to type all those numbers in. It's much, much better than just typing in 156.8. It's probably not that much different, but it's easier too. Just hit the answer key. You want to get in the habit of doing that kind of stuff. So I get 12.5. That's it. At some point you do need to round. So now that I've gotten to the last step, I'm comfortable rounding at the last step. So that's it for solving for sides. You're going to take your equation, plug in the stuff you know. That whole right-hand side you can punch in a calculator and just hit that square root of whatever you got. And you're done. So law of cosine, solving for a side, pretty easy. Okay, so now finding a missing angle using the law of cosines is going to be the hardest part of this whole thing. So I've got my triangle drawn out here. We've got sides of 10, 8, and 13. We're going to find our missing angle. Our formula, oops, I can write it correctly, c squared equals a squared plus b squared minus 2 times a times b times the cosine of angle C. In this case, the thing we don't know is angle C, which means straight across from it, side C has to be the 13. So I'm going to slide it over here. 13 squared has to be C. That is the biggest part of this. A and B can be either 10 or 8. Doesn't matter. I'm just going to go ahead and put them in there. And the cosine of, and I'll just leave it as x in there. Now, normally, before we had really nice scientific calculators, we'd have to go through and like do this piece by piece using order of operations and all that stuff. We'd take 10 squared, we'd take 8 squared, we'd multiply the three numbers together, we'd add these, and then we could start solving all of our equations. Because we've got good scientific calculators now, what we can do is we can take a few little shortcuts. And so rather than squaring the 10 and the 8 before we do anything to them, we can just go ahead and subtract them both right away. So we're going to subtract 10 squared and 8 squared from both sides. That'll cancel those out. Though this one is a little different, I'm actually going to grab my scientific calculator right now because I think it's good to do this one a little bit in parts. So I'm just going to go ahead and type what I've got here, 13 squared minus 10 squared minus 8 squared. You could definitely do this without typing everything in, but it just gets a little bit cumbersome. So 13 squared minus 10 squared minus 8 squared is 5. Awesome. So I've got the equation right now. 5 equals negative 2 times 10 times 8 times the cosine of x.
Washington, if you're in the building, please come to the main office. Damon, Washington, if you're in the building, please come to the main office.
So we've got 5 equals negative 2 times 10 times 8 times the cosine of x. Again, in the past, we'd have had to multiply these three numbers together before we divide them. But now I'm just going to go ahead and just divide by everything that you see here because the calculator can handle that. So 5 divided by negative 2 times 10 times 8. And each of those is just going to cancel out. I'll go ahead and bring my calculator back over here. And I'm just typing in what I've got over here. This is another place where I can just use the previous answer button if I'd like. That makes my life a little easier. And I can use the parentheses, or I can just use the times symbol. Doesn't matter. As long as all of those are in the bottom of the fraction, that's what really is going to make a difference. So when we do that, we've got negative 0.03 stuff. I'm going to leave that value stored in my calculator, and I'll show you how to deal with that. But 0.03 blah, 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 blah equals cosine of x. And now this is the point where if I want to solve for an angle, and I know what the cosine is, I can use the inverse cosine to do that. So I'm going to go ahead and take the inverse cosine of my thing, negative 0.03, and that's going to give me my angle. All the inverse cosine does is I put in what the cosine is, it spits out the angle. And so I'm going to go ahead and use my calculator to do that part. What I'm going to do for sure is I'm not just going to type in inverse cosine of negative 0.03. I'm going to go ahead and start a new line, leave that value there, and I'll do inverse cosine of the previous answer. And it's actually plugging in even more numbers than that. It's plugging in the exact value. So when I do that, I know that this is as exact as I'm going to get. 91.79 or 92 degrees. And just as an example here of what would happen if I didn't use the previous answer button, and I just did inverse cosine. Oops, now I'm doing annoying things. And I just did inverse cosine of negative 0.03. In this case, it's not too far off. It actually would round to 92 as well. But you will find situations where if you round that number off, it could give you some very strange answers. So I get 92 degrees there, and I've solved for my x. So just as a reminder here, little c and big C, one of those two things is what you're solving for. If you're solving for a side, then the opposite angle goes here. Here we were solving for an angle, so the opposite side went there. A and B can be either side that's left over. It doesn't really matter which one's which. And when we're solving for this angle, this is the hardest thing we're going to be doing this chapter. We're going to do it in steps. We're going to write it out, because when we write it out, we can see, oh, I've canceled those out. I've subtracted them on the other side of the equation. I've divided by the things I need to divide by. I've done my inverse cosine to get my answer. We trust our algebra. We know how to do algebra. We're going to trust in our skills to do algebra. We're not going to try to take shortcuts and do it all in our head, because there's just way too much here to try to do that with.